So we're given a question where we are told a computer company received a rush order for as many home computers as could be shipped during a 6-week period. Company records as follows. So in this case, first of all, you need to count the number of observations in here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 6 by 7, the total observations that we have here is about how many? 48. Well, 6 by 7 is 48. So to find the class interval, you need to use a formula. You don't just guess. The formula that we use is 2 to the power k. 2 to the power k. So in this case, what we need to understand is that our n should be greater or equal to the value of k. So I said we have how many elements, observations? 48. So we must look for a number that we're going to power this to be greater than 48. So you need to understand 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. So you look at the numbers which will first exceed what? 48. So 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 6, is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6. What is 2 to the power 6? 64. 2 to the power 8 goes on 128. So you look for a number which first exceeds 48. Is it this one? No, 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 no. But this one, it first exceeds 48. So meaning we're going to choose our k as 6. So we're going to choose our k as 6. So this is where the 6 is coming from. So you identify the highest number here minus the smallest number. Our highest number is 87. And the smallest number here is 22. So subtract 87 minus 22 divided by 6. We're getting 10.88, which approximately is 11. So once you do that, now you can identify your classes. So classes, we're going to start with what? The smallest number here, which is 22. Add 11, 33, 44, 55, 66, 77. Then here subtract 1 from this one, this is 32, 43, 54, 65, 76, and what? 87. You need to understand that this class width here, from here to here, you need to add a 10 because it's non-inclusive. If our class interval is 11, just add a 10, 22 plus 10, 33 plus 10, 44 plus 10, 55 plus 10, 66 plus 10, because there are 11 elements in the actual sense. Is that clear so far?
Maybe I missed where the 6 came from, because with me, I just counted the table, but now I counted the rows. That's what I was thinking. But now I realize, how about if they just bring something that is scattered, not in a table?
Yes, so it's a number. So if you had, how many? If you had about 120 numbers, you're okay using this table. You need to look at this. You'd have picked it. The 6 to the power 7. Your number of classes would be 7. So it's not just arbitrary. It was calculated. So most people do not realize that. You get it, right?
Collins, where did you get the 48 from?
How many observations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All these are how many? They're 48. Our n is 48. This is 6 times 8. Then multiply these numbers, you get 48. All these observations are 48. So to understand the number of classes, to divide the range in, you first identify the number of observations, 48. Then you use this table that I've given you here to say 2 to the power 1, 2, 3. You look at a number which first exceeds 48. It's not 32, but it's 64. So what is our K? 6.
Sorry, Collins. It's not that I'm wasting your time. It's 42. Count. It's
Yes,
42, not 48.
so even if it's 42, which number first exceeds which
It's
number?
the same one.
Yes. Okay. Are we together?
Yes.
So when you multiply 6 by 8, is what? It's not 42, it's 48 though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 42. So even if it's 42, the logic is still that our the K here is supposed to be 6. Are you getting where the logic is coming from? The K is what? 6. So that is where we're going to get our 6 coming from there. So after you get that,
That's the question.
There
why you were putting that's the range, right? Like the 10 point something that we found. That's what will help us come up with our class
we did this.
with it.
Yes.
So what do I do to the 10?
10.5, you round it up, which is 10.8 is as good as that 11. So this is a class
11,
interval.
yes.
So you start with 22. The quickest way to not make an error. Once you get 22, you add 22 plus 11 is 33, 33 plus 11, 44, 44 plus 11, 55, 5 plus 11, 66, 66 plus 11, 27. Then here, don't put 33. You add 22 plus 10, because if you have numbers with the class with it, there's a
22
something.
plus 11. Huh?
Don't add 22 plus 11, 22 plus 10, 33 plus 10, 44 plus 10, right? I repeat, if you get the smallest number, 22,
Are you there, Collins?
yeah, I'm here. Do you understand how to do the class with it? So
Yes, I do.
33, 44, 55, 66, 37.
Yeah, the first ones you said were adding at 11. The second one were adding a 10 to the first.
All right, so then we now manually try to find the frequencies. So when we go in here, we'll check numbers. Because here you can't put 22 to 33 because it's 33 starting from there. That's what I'm saying. Here we've been adding 11, 11, 11, 11, 11. Then here, add minus 1, you're adding plus 10, plus 10, plus 10. All right? Because we're going to add 22 plus 11 will be 33. And then again, you're starting from 33. So when you have a 33, where would it fall? In here or in there? That's what I'm saying. If here it was 10, you're going to add plus 9. If here it was 9, you're going to add plus 8 this side. That's how we do it. Is that clear?
Yes.
Then you start counting between 22 and 32. How many are they? You manually check. There are 4. You write 4 there. Between 33 and 43, how many are they? You count here. You find how many 4. Between 44 and 54, how many are they? They are 9. Unless you want us to count manually, but these are accurate. Between 55 and 65, they're 14. Between 66 and 76, they are 6. Between 77 and 87, they are 5. Okay. Are we together?
Yes.
The total comes to the 42. And how to calculate the relative frequency? 4 over 42, we're going to get 2 over 21. I'll leave it as a decimal. Then here, 4 over 42, we get this. 9 over 42, we get that. 14 over 42, we get that. So you keep dividing throughout. All right? So that is how we are getting the values at the end there. Are we together?
Yes.
Is everyone at par?
Yes, yes.
Yes.
Okay. So,
On my end, that's what I wanted to find out.
all right, let me even go to the next
And
one.
then
And this, you have another question before I proceed?
no.
All right, so this is just a touch and go. Each one of you has an opportunity to
I
ask
also have
a question that you are not
colleagues, I have a question on the box and whisker plot, but when you're done with this,
Okay, so I can go to box and whisker plot.
when you're done with this, yeah, when you're done with the stem and leaf.
So stem and leaf has the dimensions as follows. The smallest number is 0.8, and the largest number is from there is about 93. This is the smallest number, and this is the highest number. So point number 1, you need to write all the values from 0 to 9. So 0, 1, 0, 2, 0, 3, 0, 4, 5, 6, 7, 8, and up to 9. Whether it has figures or not, that is rule number 1. So on the zeros, we only have 8. So 0, 8, you put there. On the ones, there's nothing. So don't put anything, not even a 0. On the 2s, nothing. On the 3s, nothing. On the 4s, nothing. Then on the 5s, we have 54. That is our 54. So 5, 4, that's a 4 there. We have 56, which we need to look for, which is 5, 6. Here there was an error, so I corrected it in class. So we're done on the 50s. On the 60s, we have what? 61, 62, 63, 63, 64. On the 70s, 72, 73, 74, 78. On the 80s, 81, 83, 83, 86, 87, 89, 88, 89. And 90s, we have 93. So this is how you draw a stem and leaf diagram. So how do we describe the shape of the diagram? By drawing like this, you're able to tell where it's stretching. But this one is skewed where? It's skewed to the left. So if you're going to draw it, discover that it is spread when you transpose it. You discover that it is, you can tell from the shape of the diagram that it is skewed to the left. It's longer on the left. Okay. So the data is skewed to the left, as can be seen from this scatter plot. Part 3, are there any outliers in this 2 marks? So outliers, you can use the formula. So how do you calculate outliers? How many numbers are these ones here? They're 20. So 20, you're going to find a quarter of n, which is 20, half of n, which is a second quarter, and 3/4 of n, which is what? The third quarter. So a quarter of n here is 5. So when you get a definite number, you get the fifth number and the sixth number. 1, 2, 3, 4, 5, 6, 6. So this is our first quarter. So 62 and 63. When we average them, we're going to get what? 62.5. So whenever we get a definite number, we do what? We average it. That number and the following number divided by 2. If you get an integer number or a decimal number, we always round up, whether it's 5.1 or we get 5 point what? We get 5 point anything. So we round up. Are we together on that point?
Yes.
So how do we find now our second quartile? Somebody?
We can't do a 10th number.
The 10th and the 11th number.
So the 10th and the 11th number, okay? So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here the average is 72 plus 74. What do we get? 73.5. Then finally, here we get what is our answer here? We get the 15th number. Okay. 10, 11, 12, 13, 14, 15, and 16. So the average of 83 and 86, what do we get? 83 plus 86, we average it.
$84.5.
Hello, Collins, are you able to get me?
Yes, I'm able to get you.
Sorry, I have a question. My network threw me out. What we learned earlier, you taught us earlier to say when finding the first quartile and whatever, the formula is 1/4 times n plus 1. But here you're not putting the plus 1.
You miss my class. I think I was very clear on that one to say, don't put n plus 1 because in his class, he's emphasized n plus 1 is for undergraduate. Just the other day, it was yesterday, I was explaining to say, don't put n plus 1. So this is
Yes.
not correct. I emphasize
So
you get the same answers, but
that is not correct. So it's just to go direct.
the answers were correct, but we're using what Dr. Sabawa is using in class. So people lost marks last year because of being
N plus 1.
yes.
So it's just to go direct, 20. Okay.
Then the rule is if you find a number which is a definite number, you are going to do what? If you find a decimal number, you round up. If you find the whole number, you average that number and the next number. Okay, so the lower quartile, we're going to find 62.5. The upper quartile, 84.5. The difference between the two is called what? Our interquartile range. So how do we draw the stem and leaf diagram? You can draw it in two ways. So
Whisker boxer.
box whisker plot, have the minimum value of x, we have q1, we have q2, we have q3, and maximum value of x. So interquartile range was the difference between the highest number and the smallest number, which was what? 84.5 and 62.5, which is 22. Okay. And when you multiply 1.5 times the IQR, we get the correction term. Multiply 1.5 times this, what are you getting? 33. Okay, so the lowest number from the observations that we had was 0, 8, and 93. 0, 8, so here we're at 8 and 93. Okay, the lower quartile we found as what? What was our lower quartile? We found as 84.5 and 62.5. So 62.5 was the lower quartile, 84.5 was the upper quartile. And you had 84.5. So we're going to add this correction term to identify the outlier. So here we subtract minus 33. Here we add plus 33. So what are we going to get? 62 minus 33. What are we getting?
29.
We get what? 29.
29.
29. Then when we add 84.5 plus 33,
117.5.
meaning we're going to have 117.5. So this means that we need to redraw our what? Which one is our outlier from the observations? If the minimum value is what? Between the extreme values are between what? 29 and 117.5. So which one's our outlier?
8 and 93. Oh, 8 and yeah, 8. Just 8.
No, it's just 8.
So just 8, all right? So
It's
8,
according to
8 will be out. So you need to redraw now the box Fisker plot. So meaning our minimum value will be as follows. Our minimum value will be what? Whenever you're drawing, you need to draw to scale. Okay? Whenever you're drawing, you need to draw to scale. When you put the number line here, okay, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 7, 75, 8, 85, 90, 95. So the smallest number is no longer 8. What is the smallest number of x? Since we cut off the 8, it's 54. All right? So our box Fisker plot will be what? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 95, or 100. So the minimum value of x is no longer 8 because it's an outlier. We're not going to consider it. It will be starting from 54 to 93. So you draw at 54 somewhere here, and at 93 somewhere here. You draw this. The outlier is at 8. Just put a point there. That's where the outlier is. Then our quartiles. We know that our quartiles, we have the lowest quartile as 60 what? As 62.5 and 84.5. 62 and 84.5. So here 62 and 84.5. So this is x mean, x max. Okay.
This is why I have a problem with how you know where to draw the, because I'm seeing 50 something and 90 something.
You're seeing what?
like the way you've drawn it, like how do I know that it's supposed to start from 50? I don't know if it's 50
It's an
something.
approximation because the lowest number, C, because we've identified an outlier. Our outlier is what? Our outlier is 8. So meaning 8 cannot be the smallest number. So we're going to start. Our minimum value of X is what? 54.
54.
And the maximum value of X would be 93.
93.
Yes. Okay. Then our Q1 is, what is our Q1? 62.5. Q2, Q3 is 8.4.
Q3 is 84.5.
Q1
Q2 76.
4.5. Then this one is what? 84.5. So 62.5. And our median was what? What was our median? What did you find as our median?
76.
76.
That's the Q2, right?
Yes. So 76. So I also could tell you that you're able to tell whether it's skewed to the left or to the right if the difference from here to here is larger. From here to here, the difference is larger here, then you say it's skewed to the left. If it's larger from here to here, it's skewed to the right. Okay. So
Collins, I've understood how you've explained it, but the one that we learned the day before yesterday, this one, it was cutting per 3. That was minimum was 3 and the maximum was 72. But it was cutting on 3 and 30 something. That's why I'm getting the confusion from.
I explained it the same way. You just need to revisit those your notes. All right.
You're saying?
I explained it the same way I have explained it now. It was a different question, but it wasn't, I don't know, it's an assignment. All right. Any other question? This is
Hi, Collins.
Yes,
Can you
please.
just maybe repeat, joined a bit late, on how to find the Q1, the formula for Q1 and Q3?
The formula for the quartiles. Said, if you have a data set rearranged in order from the smallest number to the highest number. First of all, I said when you're doing the stem and leaf diagram, the figures that don't have anything, please put them there, even if they don't have anything, because they're important for you to know that it's skewed to the left, to the right, because some people lost marks because they wrote to 0, 5, they left out this part. All right, point number 1. Point number 2, I've explained to say if you have a data set from the smallest to the biggest, if you want to find the quartile, don't use a quarter of n plus 1, no. Use a quarter of what? N for the first quartile, half of n for the second quartile, and 3/4 of n for the what? For the third quartile. So n is 20. A quarter of 20 is what? 5. So you count. You don't pick the 5th number, but the 5th and the 6th number. Whenever you get a definite figure, you for instance, if you get a 5, it means what? You're picking the 5th position, that's the 6th position, and divide by what? By 2. If you're getting a 5.1, you round off to 6. Even if it's 5.9, round off to 6. So all decimals, you round up. If they're definite figures, you average them. Is that clear? So here we got.
Yeah, okay. So the formula is for a quarter is 1/4 times n. N is the number of
Observations. Yeah.
Okay.
So 1, 2, 3, 4, 5, and 6. So you average this too. That's how we got 62.5. Then half of n is 10. So 10 and 11. So this is 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we average this. So Q2 got 73.5. Then Q3 is 15, 11, 12, 13, 14, 15, and 16. You average these two, which will give you what? 80. 4.5. These are the figures here. Are we together?
Yes, fine.
Then the other thing that I've mentioned is say after you find the interquartile range, smallest value minus highest value, you get 22. Then there's a formula to find the lower bound, Q1 minus 1.5 IQR. So 62 minus 33 will get a what? 29. Then here the upper bound, Q3 plus 1.5 IQR, we're going to get 117.5. So this is our interval, 29.5 and 117.5. Any number outside that is an outlier. So in this case, our 8 is an outlier. So now it will help us decide how to draw the Bose-Fisker plot. So meaning our minimum value is not 8 because 8 is outside. From here, the minimum value we're going to consider is what? 54. So we're going to write 54 here. Then 93 here. Then we're going to do what? To draw our Bose-Fisker plot. Here it is what? 62.5. And here we have what? 70. We're going to do what? 62.5, 17.5. Then our median is what? Our median 73.5. This is 84.5. So the difference between this and that is about what? 11. The difference from here to here is about what? Almost 11 as well. So this is normally distributed. It's the same, 11, 11, normally distributed. But if it's 12 here and that is skewed to the right, the left. All right. So we go to another question here. So ideally, I wanted people to bring questions that they're not comfortable with. I tailor it to where you're behind, but if you don't have, I'll still keep going through what I feel I can take you through. So we're given the following information: the number of defective components are 1,000. So we're asked to find the arithmetic mean of defective components. Now here, I've always told you to say, we do a reciprocal. Firstly, we multiply this by that, this by that, this by that. So I'm multiplying the number of boxes by the number of defective components. So 0 by that, we get this. 0 by that, we get this. 0 by that, we get this. And the total is 2,000. If they're asking us to find the arithmetic mean of defective components, we divide this by the number of boxes, the number of the other sum. So 2,000 divided by 1,000. If they ask us to find the arithmetic mean of the number of the number of boxes, okay, we're going to divide this 2,000 by the total sum here. It reciprocates. This question is similar to what came last year for the different ratings locations. I don't know whether you remember that question. So people had a challenge in identifying what to divide the 2,000 by. So if it's asking for defective components, don't get the total of the defective component, no, get the total of the number of boxes. They divide 2,000 over 1. They ask you to find the arithmetic mean of the what? Of the boxes. We divide them by the sum of the number of defective. I think that's what I can explain to simplify your work. Is that clear? So our mean was 2.
Mr. Collins,
Yes,
sorry, can you come again just on how the question comes in terms of you said arithmetic mean and I didn't get you clear.
I'm saying at this point, we have 2 options. When it comes this one, like this exactly, let's memorize the answer here, what we've done here, okay? don't think too much. Total up, divide 2000 by 1000. But if it's swapped, which is most rare, here is being asked to find the mean of the defective components. So this total for both of them, this one is non-debatable. But what are we dividing it by? Because if I total up here, this is 10, this is 20 and 21. So am I dividing it by 21 or am I dividing it by 1000? So if they're asking us to find the average for the number of boxes, we divide it by the total of the other. So 2000 divided by 21. If they're asking us to find the mean of the defective components, we divide it by the total of the other, which is 1000. Is that clear?
Yes, thank you.
Exactly. All right. So here we're given distribution, the factory. We're being asked to draw an or give and define the limit of weekly wages over 50% of the workers. Then estimate graphically we end that. So here we're going to use the upper bound against the frequencies here. So to draw that, we're going to get the cumulative frequency. 69 comes there. We add 69 to 167. We add 3 to 36. We add this to get 440. We add 65 to get 508. We add 58 to get this to get that, this to get that. So the total is what? The total is 600. How do we get that firstly on the frequencies? Are we together on how to get the cumulative frequencies?
No, just come again.
Frequencies is just an add-on. Everything has been given here, cumulative frequency. 69 comes there. We add to 167, we get 236. 236 plus 207, we get 443. Plus 65, we get 508. Plus 58, we get 566. Plus 24, we get this. Plus 10, we get that. Is that clear?
Yes.
Yes. Now to come up with the or give, we're just going to be using the upper bound. 875 against 69. 950 against that. So we're getting just the upper bounds there. So we're going to get this against that, this against that, this against that, the upper bound. So we're using the cumulative frequency and the upper boundaries. So this is giving us the or give, which is looking like this. So this is how we can come up with the or give. Then they ask us to find 50% of the workers represent the median. So if you're going to scale, 50% of 600, because the total was 600, 50% of 600 is 300. So 300, when you push it there, it will give you an approximate figure of what to get down there, which will be about 9 something, 980, 85. If you're going to use a graph, I doubt if such a question can come because you need to plot it to get an approximate, which is there. If they ask you to find 25%, which is a quarter, 25% is a quarter of 600. So you go to 150. So 150 is somewhere here. 150, when you go to scale, you want to find the corresponding figure here. You take you to 910. Then the upper quarter is 3/4, which is 75%. So 75% of 600 is going to 450. And you go to 450 here to correspond to a figure here, which will approximately give you 1060. So that is how we approximate that. Okay, I'm interested in this question on the warrant. Any questions so far on the or give that we've looked at? Any questions?
Mr. Collins, after this one, we should also look at the Sudan question.
Which one?
The Sudan new.
All right.
Sudan SUV.
Okay, so we've been given a question to look at. So we're told that according to the store's historical records, 65% of its digital cameras are, according to the store's historical records, 65% of its digital camera customers are male, and 18% of its digital cameras purchase extended warrant. 10% of its digital camera customers are female and purchased an extended warrant. Determine the probability that male digital camera customers will purchase the extended warrant, then determine probability that are female more likely to purchase the extended warrant. Justify your answer. So in this case, I'm sure you people have seen this question. Who wants to try it? What are we given? Who wants to try this question? So according to historical records, we are told that 65% of camera customers are male. So 65 are male. So meaning what is the probability that they're female?
35.
35, 0.35. So you can even use a tree diagram if you want. Male, 35. Males, what? 0.35. Is that clear so far? Then what else are we told? That those that get a warrant so that 18% of the digital camera customers purchased an extended warrant, and 10% of its customers are females who purchased an extended warrant. So 10% represent what? A female, and they purchased an extended warrant. So the intersection of the two is 18%. So I'm trying to be very careful in helping you understand step by step so that you don't get lost. So you can use both this contingency table, or you can use the tree diagrams. So these ones are called the prior probabilities. Okay, so females, we're not given the total of the females, but we know that the males are 65%. So you can fill in this gap if you want. So meaning if males are 65%, the females should be what? 35%. Then we are told that those 10% of its customers, 10% of its camera customers are female and purchase a warrant. So those that purchased a warrant and are female, it's 10%. So those who had no warrant, we subtract 35% minus 10%, we get 25%. So those who had warrant are 10%, those who had no warrant are 25%. The total is what? 35%. Then we're also told that 18% of the customers, whether it's male or female, they had what? An extended warrant, 18%. So 18% is for the total. Now, since of these ones, 10% are female, so meaning those that are males who got the warrant are what? The remainder there, 8%, 0.08. We're just filling in the gaps. Then we're told that if there are males in this whole category, 8% we've just calculated that had a warrant. How many do not have a warrant? From the total of 65, we subtract 65 minus 8, what do we get? So 0.65 minus 0.08, what do we get?
0.57.
0.57. Then you can now total up this plus that. So you're going to get the totals just to finish up. Okay. What's the total here? What's the total there? Here, the total must be 1. And what's the total here?
0.82.
0.82. And the total must also add up to 1. So now we can go to the question to say, determine the probability that a male digital camera, determine the probability that a male digital camera customer will purchase the extended warrant. So from here, what is the probability that a male digital camera, determine the probability that a male digital camera customer will purchase an extended warrant? So what do we get? A male digital camera will purchase a warrant. So we're simply going to divide the 8% over. So this denotation would be warrant coming from a male. So here we calculated 8. The total for the male is 65%. So you divide 0.08 divided by 65. That is how we get there. 0.123. So this is the chance that male digital camera will be purchased. There's a probability that a male digital camera customer will purchase an extended warrant. That's about 4 marks. So you go into this, the 0.08, you divide by 0.65, and you're going to get 0.123. So this is where the figure is coming from. Then there is a second part which is asking us whether males are more likely to extend their warrant compared to the females. So firstly, you calculate probability of a female extending a warrant and you compare. So if a male we've already calculated, this is 12.3, the next calculate the warrant given that it's a female. So we go where they meet warrant and female. It's 10. And then divided by 35. Here we are divided 8 by 65. Now we're going to divide 10 by 35. What are we going to get? The probability that the warrant is taken by a female customer. So this is 28%. So we're now comparing 28% to the 12%. So we're being asked, are females more likely to extend the warrant? Yes, because females have a higher percentage of 28.6 compared to the males who are getting 12.3. Let me repeat this just for the last time, then we'll go to some other question. So according to the store's historical record, 65% of digital camera customers are males. So you go there, males, females. So the males are 65, we'll put this on original data. So warrant, no warrant. Then we're also told that 18% of camera customers purchase an extended warrant. So we'll go to extended warrant. We're told that how much? 18%. So 18% have an extended warrant. So this is where the 18 is coming from, regardless of whether it's male or female, we're not told. then 10% of camera customers are males and purchased extended warrant. So 10% are females and extended warrant. So under female and extended warrant, they are 10%. So these are the three categories. All together. And now we start filling in the gaps. So the first one is like expression paper 2. We get the difference. This manasat, it's 8%. All right. Then here we get 665. This manasat, we get this. So we put in this now and this. So now we also are able to know that the total probability must be equal to 1. For 1 minus 65, we get this. Then we subtract now this manasat, we're going to get 25, we get that. Then we add this plus that, we get 82. All together, and how to fill in this table? Then determine the probability that a male digital camera will purchase an extended warrant. So you go to the male column, 8% divided by 65. You get 12%. 12.3%. So we divide this by that. Then here we're asked, are female customers more likely to extend the warrant? So you calculate 10% over 35, we get 28%. So you agree yes, because this is more than that. That's all. All right. So this is how this question was supposed to be tackled. In this question, we have an automobile company classified by a car dealership. We're being asked to find the expected value and the standard deviation. So expected value is simply multiply this one times that, we get the answer. This by that, we get the answer. This by that. That is how we get the mean. So multiplying 0 by that, we get that. 1 plus that, 2 times that. We're just multiplying these ones here. So that's how we got 1.8. So this is how we found 1.8 by multiplying these. Then you square them, each individual. So 0 squared times that, plus 1 squared times that, plus 2 squared times that, plus 3 squared times that, 4 squared by that, 5 squared by that. The total we get, we subtract the mean squared. So after squaring each individual there, we're going to get 4.44 minus the mean, which is 1.8 squared. Our variance is what? 1.2. Then when we square root the variance, we get the standard deviation is 1.09. You get it? That is how we find our expected value. Expect a question like this to come through. Any questions at this point? Are we clear? Are we together?
Just move down a bit.
Okay. So now we go to the last question. We are told that 10% of new scooters will require warrant service within the first few months. A scooter sells 1,000 a month. So get the mean and the standard deviation. So this is a binomial normal. Whenever samples are more than 30, we use a binomial normal. The mean is simply n times p. So our p is what? 10%, which is 0.10. Meaning our q is 90%. So 90% is 0.90. So what is our n? It's np. So 1,000 by 10%, which is 100. Our standard deviation is npq. So n is 1,000, 10%, and 90%. When you square root, we get that. Are we together so far?
Yes.
So I explained
Mr.
that
Collins,
in class.
this question, Mr. Collins,
Yes, please.
this question looks like with one of the activities, isn't it?
Yes, yes,
I
yes.
think it's the one.
Yes, yes,
The
it's
first-
very right. Yeah. All right.
Hi, Collins. So this one, the sample size of more than 30. This is the one that we use this formula.
Binomial. Yes.
The one with the sample size of less than 30, that's the one with the Z-score, right?
Yes, yes. So NP, we multiply 0.1 by that. Standard deviation NPQ. Then the moment skewness of skewness, we now calculate Q minus P over standard deviation. So our Q was what? 90%, our P was 10%. Then our standard deviation we found 9.49. So we divide 9.49 into 80%. So our moment skewness is 0.84. I repeat. The examiner now is asking us to calculate the moment coefficient of skewness. So the moment coefficient of skewness is simply Q minus P over standard deviation. 90% minus what? 10% over the answer which we found here. It's 9.49. So the answer will give you 0.084. The kurtosis is given by 1 minus 6PQ over the variance. So 1, 6P, 0.1Q, 0.9. The variance before it's square rooted, it was 90. So when you calculate the answer, we get 2.051. So that's what we call the kurtosis of the distribution. Kurtosis simply measures the height. Skewness simply measures how we are bending to the left or to the right. Is that clear? So these are formulas that, not all the formulas are given, by the way. So they're just to aid you. So just get to know which formulas to use when. So this is where our assignment review ends.